This is the first video for the Solving Linear Equations module of Transition Maths Plus. In this video we're going to look at sections A to C. The objectives of this module are to check if an ordered pair is a solution to a system of linear equations, to solve systems of linear equations using the substitution method, to solve systems of linear equations using the elimination method, and to solve systems of linear equations using the graphical method. So in this module we have three methods of solution: substitution, elimination and graphical. Our last objective is to come up with a system of linear equations ourselves for application problems and then use those equations to find a solution. Now, it is possible to solve a linear equation using algebraic methods. Now, it is important to realise that we are using algebraic methods here. We aren't just going to guess and check or just pull a value out of the top of our head. We need to use an algebraic method to do it. Now, solving equations involves isolating the required variable. So that just means getting it on its own. To solve multiple operations, equations for one variable, you need to do it step by step. So it's not always just going to take one step. To do this, we need to determine the number or term that is least held to the variable. We need to decide which operation is being performed on that number of term. And then we need to do the opposite to be able to undo the operation. And we repeat these steps until the variable is isolated. So let's look at some examples. It says to solve the following equations for the required variables. Okay? Now, in the first equation here, our unknown is m. Now, what's happening to the m? The m is being multiplied by 3, and then 4 is being added, and the answer is 19. So the last thing that happens to the m is this plus 4. So we need to get rid of that first. The opposite of adding 4 is taking 4. So we're going to take 4 from both sides. So my next line is 3m plus 4 take 4 is 0. So it's gone, equals 19 minus 4 is 15. Now m is being multiplied by 3, so the opposite is to divide by 3. So 3m divided by 3 gives me m equals 15 divided by 3 is 5. So that's my solution. Now we can check it. Our equation was 3m plus 4 equals 19. So the left hand side was 3m plus 4, and we just found out that m was 5. So plug it in. 3 times 5 plus 4 equals 15 plus 4, which is 19. And that equals the right hand side of my equation there. So we know it's correct. Now in the next example, it's also one variable, so the x is there. Now there are two ways of doing this one. You can think that the x minus 5 in the brackets is being multiplied by 2, so you can divide by 2 first, or you can expand the brackets first. Now which way you do it really depends on what's on the other side. Here we have a 12, so if I divide it by 2 first, 12 divided by 2 is 6, so that works, which is nice. If over on this side we had an odd number, such that when I divided by 2 I got a fraction, then you'd probably be better off expanding the brackets first. Okay, so in this case we're going to divide both sides by 2. So my next step is x minus 5 equals 6. Now looking at the unknown, which is x, 5 is being subtracted from it, so the opposite of subtracting 5 is adding 5. So now my next line I have x minus 5 plus 5 is 0, so that's gone. 6 plus 5 is 11. So my solution is 11. Again, you can check it. I'm just going to look at the left hand side, which was 2x minus 5, and I'm going to plug in the 11. So I've got two lots of 11 minus 5 is 6, which is 12, and that equals my right hand side. So that's correct. Okay, next one. 3 minus 2f, so my unknown's f, all divided by 5 equals 1. So let's think about what's happening to that f. It's over here, even though it's second in the equation, the first thing that happens to it is being multiplied by this negative 2. Then it's being having 3 added to it. Then it's all divided by 5. So the first thing we need to actually get rid of is this 5 down the bottom, because that's the last thing, sorry about that, that's happened. So the opposite of dividing by 5 is multiplying both sides by 5. So when I multiply this left hand side, we've essentially got 1 over 5 here. 1 over 5 times by 5 is 1. So that fraction's gone. 1 times 5 is 5. Okay, again, here's my f, and it's being multiplied by -2, and then we have this 3. So we need to get rid of that 3. It's a positive 3, so I take 3 from both sides. So now my next line I have -2f equals 5 minus 3 is 2. Now f is being multiplied by -2, so we divide by -2. So my next line is f equals 2 divided by -2 is -1. So that's my solution. Again, we can check. My left hand side was 3 minus 2f all over 5, which is going to be 3 minus 2 times -1 divided by 5. 3 minus 2 times -1, well 2 times -1 is -2. 3 take -2 is 3 plus 2 all over 5. That's 5 over 5, which is 1, and that's equal to my right hand side. So that works. Okay, so that is how we solve linear equations. Now simultaneous equations are a bit different. We don't just have one equation now, we're going to have two equations. So simultaneous equations has two linear equations of two variables or two unknowns. Okay, so we're going to be finding two different things now. We can also have three equations of three variables, but we won't be dealing with that in TM+. Now the solution to a system of linear equations is the values for each of the variables that satisfy all of the equations at the same time, and that's why we call them simultaneous. They all have to work. Now the methods of solving simultaneous equations are sometimes, we just say we're solving simultaneous equations. Okay, so the methods of solution of systems of linear equations is just called solving simultaneous equations. Now, checking solutions is important. Now, I've already kind of showed that for our linear equations. How do we do that for systems of equations? Okay, now often the solution will be given to us as an ordered pair, and the idea is to see, is that an actual solution for the equation? So the first example I have here is determine if the given ordered pair is a solution to the following systems. And we have two equations here. We have 4x minus y equals 5 and x equals 3y minus 7. And it's telling me that my ordered pair is 2, 3. So this is saying that x equals 2 when y equals 3. Okay, so let's look at our first equation, 4x minus y equals 5. The left hand side is 4x minus y, but we have x is 2 and y is 3, so let's plug it in. 4 times 2 minus 3. 8 minus 3 is 5, and that is equal to the right hand side. So that works. Now we look at the next equation, x equals 3y minus 7. Okay, now the x is on its own on the left hand side, and my main equation's on the right, so I'll look at the right hand side to start with. 3y minus 7, so 3 times 3 minus 7, 9 minus 7 is 2. Now my left hand side was x, which is 2, so that equals my left hand side, so that works. So therefore 2, 3 is a solution to the system. And we're done. Okay, now here's one for you to try. It's x plus 2y equals 0, 3x minus y equals -5, and it's asking whether -2, 1 is a solution. So you might want to pause the video now and try that one on your own. Okay, the solution is in the textbook. It's the second example. What now? Well, what you need to do now is complete the exercise in the textbook, and the exercise you need to complete is Syle C1. If you do have any problems or you don't understand something, remember to contact the course coordinator.